Hello, this is the second lesson in Unit 4. In this lesson, we're going to be focusing on number 2 objective, which is recognize the terms associated with simple die piercing, and objective 3, which is rationalize the relations between die clearance, part quality, cutting forces, and punch and die life. Okay, let's talk about simple die piercing. Okay, in this case, in this example, what we're doing here is we're making a round hole. Okay, what we have here is the punch, and then we have the die here. This little piece of material in there, that is the blank. And then what happens is the punch comes down, and what you're seeing here is the slug that comes out. So what we're doing is punching a round hole. Now, some of the terminology that goes along with simple die piercing is shown in this slide. Okay, so this would be a section view of a successful hole cutting operation involving normal die clearances. We're going to talk about a lot about normal die clearances in this lesson. If you look, there is what we call a shear edge, a nice shiny edge here, and then that's both on the slug that gets punched out and also on the material. There's going to be a nice shiny edge up in here. And then once it builds up enough force, the material shears, and then you get this fracture surface. You can see it here and see it here. This is typical of die piercing operations and punching operations. In fact, you can see this on any parts or washers. Just take a look at a washer. Okay, so right here I've got this little wrench that I found laying around, and obviously it's a stamped part. Now, if you compare that to the previous slide, what we see here is this nice shiny edge here. That is the shear edge. Okay, that is the shear edge. You can tell that the part was punched from this side. Okay, and then here is the fracture surface, the breakout surface. Okay, so look at a washer, because most every washer that you'll see at the hardware store is produced by a stamping operation. Okay, and let's examine this little wrench a little bit further. Okay, so in this slide, we're looking at the face of the wrench from the shear side. Okay, that's the side with the shiny edge. And as you can see, the edges of the part are slightly rounded over. Okay, and this is what we're talking, a trade-off between proper die design clearance. Now, if we looked at the back side, the fracture side of the wrench, look how different it is. Okay, so this, you can see in this view, you can see the fracture side here, and then the edges here along the outside of the part are nice and sharp. Okay, so you'll notice this, unless those edges have been cleaned or ground, which probably isn't done on washers, but you'll notice that if you look at pretty much any stamped part. Okay, so how much force does it take to stamp out a part? So typically, what, a round hole 1 inch in diameter is punched into a 1/16 inch sheet of 1010 carbon steel. How would you calculate the force required? Okay, so what we need to do is look at the shear area. Okay, when I'm talking about shear area, I'm talking about the surface around the inside of the hole, or the surface around the outside of the slug, okay, which is essentially the circumference of the hole. So the shear area is going to be the circumference of the hole times the thickness. And then the force is going to be the shear strength of the material times the shear area. Okay, so that's how you calculate the load that it takes to punch out a hole. So let's talk a little bit about die clearance. So die clearance allows the blank to eject cleanly, which prevents jamming and helps with tool wear. So proper clearance depends on the workpiece material, the thickness, the hole size, and the other finish requirements. So generally, if you have too tight a clearance, this is what's going to happen. You're going to have high cutting forces. You're going to have the slug being stuck from the die. You're going to have a tendency for double breakage. Now, what is double breakage? That's this slide here. Double breakage, in this case, you see the nice shiny shear edge. Oh, then you got another shear edge too. If you look at the part that's been stamped, that is an indication of insufficient die clearances. Okay, double breakage occurs when not enough die clearance is used. Now when you have sufficient die clearance, okay, it starts the start of the punch penetration and fracture with relatively large punch to die clearance. Okay, the fracture paths will be nice and even, and then here we got die clearance. If the clearance is too large, the edge may be rolled. You see that on the wrench. Okay, on the wrench the edges were slightly rolled. If you had too much die clearance, you're seeing the edges on the shear side would be very rolled. So you can't really have that. Okay, so here's a picture of too much die clearance. We're calling it generous die clearance. Okay, you see the rolled edge here, you see a nice shear edge, and then there's a fracture surface, and then you're left with a burr on the same. That's like too much die clearance. Okay, so when the metal is punched out in the functional part, the metal around the opening is scrap, the die is made to the desired part size, and the clearance is subtracted. But when the slug is discarded, the punch opening is functional, the required clearance is applied to the die side. Okay, and then this slide just talks about how you apply the die clearance to irregularly shaped holes. So that concludes this lesson. We're going to talk about objectives 4, 5, and 6 in the next video. Thank you.